Hello everyone. Today we will discuss about the work done on an inclined plane. We have already studied about friction. So we are considering the surface as that of the friction. So work done on an inclined plane. Here we will take two cases when the work is done in moving an object up an inclined plane, and second case we'll take when the work is done in moving a body down an inclined plane. So first we are taking the work done in moving a body up an inclined plane, right? So let's first draw the diagram. This is the inclined plane, and on this inclined plane we have this block of mass m, right? We are applying force along this direction to make it move up an inclined plane. Now since it is applied forward in upward direction, so the friction force will be along opposite direction. This will be kinetic friction. We know that the weight of the body always acts downwards. So this is the weight of this object. Suppose this is the angle theta for this inclined plane. Now in this case, we are considering that this motion is without acceleration. So what does that mean? That means we have to consider that this side forces are equal to the opposite side forces, right? So since the motion is on the inclined plane, we are considering this as our horizontal and this direction as our vertical direction. Now we have to mark the one more force which is acting on it. What is that? Since the block is on this inclined, so the normal reaction force will be normally outward to this inclined plane. Now if this is our vertical and this is our horizontal, so that means all the forces must be along this and this direction. Now R is already along this vertical, friction and applied force both are along this horizontal, but this mg, that is the weight, is in the downward direction, which is oblique. So I need to find the components of this weight along this horizontal direction and this vertical direction. What will be those directions? This one and this one. Now we know that this angle will be theta. Why so? Let's complete this. This is 90. This is theta. This is 90 minus theta. So this will obviously be theta. Let's remove it and then check. This is theta. This is 90. So this angle will be theta plus 90 plus, let's mark this theta dash. Theta dash is equal to 180. So theta dash will be 90 minus theta. If this is 90 minus theta, so obviously this angle will be theta, right? So since the diagram is messed up with this calculation, so I'll just rub this part. This was for the explanation, so I can move forward with this diagram now. So mg, its component along theta, I know, I have already told you that mg has this cos theta component along the theta angle, and perpendicular component will be mg sine theta. Let's consider this condition that for this side forces will be equal to this side forces. So I can say that F is equal to mg sine theta plus friction force, right? Now what is the formula for friction force? Friction force is mu k into normal reaction. Now check this. The body is on the inclined, it is moving parallel to the inclined. It's not moving in this vertical direction. So this R force is balancing this mg cos theta. So R is equal to mg cos theta. Therefore, Fk is equal to mu k mg cos theta. If I mark this as 1, this as 2, so I can write here that from 2 in 1, right? Now this I am marking as equation 3 and this I am marking as equation 4. So putting this value in this equation, so force from equation 4 in 3. What will be the expression for force? This will be mg sine theta plus mu k mg cos theta. Now what is the formula for work? Work is equal to force into displacement. If S is the displacement here, so this will be mg sine theta plus mu k mg cos theta multiplied by the displacement. I can take this mg common. So mg is outside. Now this will be sine theta plus mu k cos theta multiplied by the displacement. So this is work done in moving a body up an inclined plane. Now I'll consider the case for work done in moving a body down an inclined plane. So that again without acceleration. So work done in moving a body down an inclined plane. Why I am solving this on the right side? So that you are able to compare the two cases. So I am drawing the diagram here. Inclined angle theta. So let's mark this mass m. Force is applied this way. Why this force is applied? This is, we are trying to move it along this direction. The weight is acting downward, always downward. Friction force opposite to the motion. So I have to mark this opposite to motion. Normal reaction, normal to the surface on which it is placed. So this is normal reaction, right? Now again, as before, I'll have to find the components of this weight mg. So here I don't need to explain you again that this angle will be theta. So this will be mg cos theta and this direction will be mg sine theta, right? So from here, if there is no acceleration, then obviously this plus this force must be equal to this force, right? So this F plus mg sine theta is this side force and opposite force is Fk. And as before, Fk is equal to mu k into normal reaction, and also normal reaction is mg cos theta. As before, there is no this side motion. So therefore, Fk is mu k mg cos theta. So if I mark this as equation A, equation B, so from B in A, right? So I'm putting this value. So the force is plus mg sine theta is equal to mu k mg cos theta. I can find F by shifting it. F is mu k mg cos theta minus mg sin theta. So work done is force into displacement. So I can write this mu k mg cos theta minus mg sin theta multiplied by the displacement. Now I can take mg common here. So this will be mu k cos theta minus mg, sorry, mg I have taken common. So this will be minus sin theta into displacement. So this is about the work done in moving a body up, and this is in moving the body down an inclined plane, right? So I hope this topic is clear. Now the next topic will also be considered in the same video, because here we will be finding the acceleration of a body on an inclined plane, right? So since the concepts are similar, I am taking it here only. So for acceleration also, we'll take the inclined plane, but one necessary condition is there. Acceleration of a body on an inclined plane, right? Here the important condition is that the angle is, minimum angle is angle of repose. So if minimum angle is angle of repose, so angle theta is equal to angle of repose. So what is repose angle? Minimum angle at which the body slides down on an inclined, right? So the diagram will be very similar. Again here the mass, right? So it's sliding down. So friction force will be this way, right? Weight is acting downward. We are not applying any force. So normal reaction here. But we need to find the components of this weight. This will be mg cos theta as before. And here we will have mg sin theta, right? And since it is moving downwards, so the acceleration will be this way. So what is the second law of motion, Newton's second law of motion? That net force along motion is equal to mass into acceleration. So what is net force along motion in this case? This is mg sin theta minus fk is equal to mass into acceleration. Now let's put the other values. We know that r has to be straight line weight. Okay. We know that r is equal to mg cos theta in this case, and fk is equal to mu k into r. Therefore fk is what? mu k into mg cos theta. Let's mark this as equation 1 and this as equation 2. So from 2 in 1, from 2 in 1, I'll put the value of fk. So this is mg sine theta minus mu k mg cos theta is equal to mass into acceleration. I can take m common from this side. So this is g sine theta minus mu k g cos theta. So this is equal to m into a. You can take g also common. So I am just taking g also common. So this will be g sine theta minus mu k cos theta. So this is about the acceleration of a body on an inclined plane. I hope the topic is clear, and that's all for now, and have a nice day.